Okay, so we look at question 1, and the first thing we want to do is sketch the graph. Okay, and we want to note that our C is our child's dose, so that is what we're trying to equal to. We have a D, which is the adult dose, and our X, which is the child's age. Okay, so the first thing we want to do is sketch the graph of Young's rule for the medication if the adult is 500 milligrams, if that dosage 500 milligrams. So we have C of X is equal to X over X plus 12 times 500. Okay, so if we plug that into the calculator, depending on your view, so if you graph it with the standard view, your graph is going to look something like this. And remember how we talked about how some of our graphs can be a little misleading based off of the window that we have it appearing at. And so if we make our window to where we have a Y max at 500, then our graph would probably look something more like this. Okay, so we need to be sure that we fix our window to adjust it in a way that it appears more like this. So we want our X window, our X min on our window to be at 0. Our X max at our window to be at 18. And then we can have our Y also be at 0, 500. Y min is 0, Y max is 500. And we get that information based off of looking at our question. So we have to make sure to always look at our window and make sure it's appropriate for the type of way we're going to graph it. So next up we want to look, what is the vertical asymptote and does it have any meaning in this problem? So when we look for our vertical asymptote, we want to look at our domain restriction, which is our denominator in this case. So if we set 0 equal to X plus 12, I get that my vertical asymptote is equal to X equals negative 12. So now we have to think about does this have any meaning? Well, the question is X is the child's age in years. So the question we have to ask ourselves is, can we be negative 12 years old? And since we can never be negative 12 years old, this has no meaning when we're trying to solve our problem. So since we can't be negative 12, years old, it has no meaning. And I'm not sure if y'all can see that. Let's see. Looks okay. So next we want to look for the horizontal asymptote and see if this has any meaning. So for our horizontal asymptote, we actually have to be careful because this 500, we have to multiply. So if we simplify this, if we make it look more like a simplified fraction, we have C of X equals 500X over X plus 12. And so we think, do we have, we look at our degrees for our horizontal asymptote. They're both 1. Our highest degree is 1 in each case. So we think SDDC. Same degree, divide coefficients, which I end up getting a horizontal asymptote at Y equals 500, because I do 500 over 1, and I'm left with 500. So does this have any meaning to the problem? So this, I would kind of accept 2 answers here. So I'm going to go ahead and erase our meaning over here real quick so I can explain. So here we can kind of have two separate answers. The answer that first came to my mind is that this has no meaning. Because what we're trying to solve for is the dosage in the dose for child's age in years, and by the time we get anywhere close to the y equals 500 mark, we're way past the child's age, which is, we know, between 0 and 18, right? Because you would be considered a child from the time you were born, so I guess, and then you become not considered a child anymore at the age of 18. Another way to look at it is this does have meaning, and that the meaning is that's the amount of dosage that you would give to an adult. So either answer you gave there, it would be acceptable. Just be sure you explain your reasoning on why you chose that and the problem. So now we look to our last question, and that is, what dosage of this medication should be given to a child that is 6 years old? Okay, so we know that our child's age is the variable, and we know that it is now 6, so we simply just want to plug in 6 over 6 plus 12 times 500. And what we could also do is, if we graph this original equation up here, this original equation right here, then what we end up doing is just going to menu 7 and plugging in 6 for our x, or if you would like to, you can do it this way as well. Either way, you should get to where the dosage is approximately equal to 166.67 milligrams. So no matter which way you do it there, that should be what we get as our solution. So that would be it for number 1. So we go on to number 2, which is another word problem. Okay, so the density D of material can be expressed as D equals M over V, where M is equal to mass and V is equal to volume. So we want to write down the equation if the mass of an object is 20 grams. So that's pretty easy. We just have D equals, and we know our mass is equal to 20, so 20 over V. Okay? So if we sketch the graph from part A, we're going to end up, let's scratch it over here. So if we graph this, we're going to end up with something that looks kind of like this. Okay, so we graphed it. So now we want to find our asymptotes. So in this equation, we have, if we first look for our horizontal asymptote, so we look at where is our degree bigger. Well, we have a degree of 0 in the numerator, and we have a degree of 1 in the denominator. So we end up with a degree higher on the denominator, so we end up going with our BOBO option, which is horizontal asymptote of y equals 0. Okay, so we have a horizontal asymptote of y equals 0. Now we look for our vertical asymptote, which is where we want to set our denominator equal to 0, and we only have a v, so we set v equal to 0, so we get v is 0. So we have a vertical asymptote where x is equal to 0. So that is what our graph now looks like. We have a horizontal asymptote and a vertical asymptote at x and y equals 0. So now we want to explain the meaning behind the asymptotes for this situation. So when we think of density, it makes sense that we have horizontal and vertical asymptotes at 0, because anything that exists must have at least some density, right? There's nothing that is going to have a density of 0. And so that takes care of our vertical asymptote. And then for our horizontal asymptote, we have to look at y equals 0, and that would be because if we had, for our vertical asymptote, we have to look at yx equals 0, and that is because if our velocity, our volume ever equals 0, then we would get a function that is undefined. So we must have something that is positive and at least has some form of density. Notice that in both instances, these are positive because in quadrant 3, we have negative and negative. So in that case, we would factor out a negative. So density must also be positive. So here we could say something like, you can't have a density of 0 or you could say D must be greater than 0. So either one of those two explanations would be exactly correct, and I would accept both of those. So that's going to be it for number 2. So we go ahead and move on to number 3 now. And we want to write an equation for the function described at a whole of x equals 5, vertical asymptote of x equals 6 and negative 7, with an x-intercept at 4, 0, and a horizontal asymptote of y equals 0. So the first thing I look at is I see a hole at x equals 5 and a horizontal asymptote at y equals 0. So I know my degree has to be bigger on the bottom, and I know something is going to have to simplify of x minus 5 on the numerator and denominator. So I'm left with y equals, and I know I have x minus 5 on top and bottom. So I write that first. Okay, I know that I have vertical asymptotes, which is a domain restrictor, meaning it must go on the bottom at 6 and negative 7. So I know that I have to have x minus 6 and x plus 7 on the domain to make these domain restrictors. So now I have this one done. I have these two done. So next I want to check for how I have an x-intercept at 4, 0. Well, I know that I have a hole here, so this is going to cancel. And I know in order to get an x-intercept, I set my numerator equal to 0 for the y. So all I would have to do here, since this cancels, is make this x minus 4. And now I have a point where my x-intercept would be set at 4, 0. So then the last thing, so this is done now as well. So now we look for our horizontal asymptote. Well, if we compare our degree in our numerator, we get 2. And if we compare the degree of our denominator, we have a highest degree of 3. So we get that it's Bobo, so that does indeed have a vertical or horizontal asymptote at y equals 0. So we are good to go there. So this would be a perfect equation for that question, and that would be our final answer. So in case you can't see that, I'll write it up here a little bit nicer. Y equals x minus 5, x minus 4 over x minus 5, x minus 6, x plus 7. And that would be your final answer for creating a graph with these, given these key aspects of the graph. Cool, so that one is done. I'm gonna go ahead and leave this one up because we do have a part C where it asks for the y-intercept. So I'm gonna leave that one up here, but erase this information. Okay, so now we're looking at part B, where we have a horizontal asymptote of y equals 5, a vertical asymptote at x equals 9, and an x-intercept at negative 11 with a hole at 2. So again, I always like to start with the hole because that's something I know pretty well. Y equals something, and I know that I have to have x minus 2 on both the top and the bottom. Okay, so the next thing I can look at is I have a horizontal asymptote at y equals 5. Actually, let's come back to that. Let's go with the vertical asymptote first. So I have a vertical asymptote, so I know that means something needs to be on my denominator that when it's set equal to 0 restricts it. So I can have x minus 9, and that takes care of that vertical asymptote. We have the whole taken care of. So then we can look at our x-intercept, which is at the point negative 11 comma 0, and we want that to be x plus 11 because we know an x-intercept is where we set our numerator equal to 0. With this being a whole, that takes that away, so we're just setting up x plus 11 equals 0. And when we do that, we get x equals negative 11. We know our y must be 0 at every x-intercept, so we're good to go there. There's no other way we could do that. So that one's good now. So here's kind of a tricky part. This is the first time we've created an equation with a horizontal asymptote of y equals 5. So we need to think about what rule it could work for this. So it's obviously not bigger on top because we would not have a horizontal asymptote. It's obviously not bigger on bottom because we would have 0. So we have to get an SDDC, same degree, divide coefficients. Well, if we look here, we have degree 2 on the top, degree 2 on the bottom. So if I wanted it to be y equals 5, I simply just need to put a 5 in front of that x minus 2, and now all of a sudden, when I divide my degrees, I get, when I simplify that down, I would get a horizontal asymptote at y equals 5. So again, I'll go ahead and write this up here as well, so you can see it a little bit better. I get 5, x minus 2, x plus 11, all over x minus 2, x minus 9. Okay, so now we want to look at C, which is finding the y-intercepts of both A and B. So I'll separate these out for you so you can clearly see. We have that squiggly line separates our A and B for us. So C, we want to find the y-intercepts. So we set all of our x's equal to 0. So here, for the numerator, we would have these cancel out when we're talking about C. So our x minus 5 cancels out. So we end up with y equals 0 minus 4. This is for A. We end up with 0 minus 4 over 0 minus 6 times 0 plus 7. Okay, so when I do that, I end up with negative 4 times negative 6 times 7. Okay, so when I do that, I get negative 4 over, what is that? 7 times 6 is 42 over negative 42. And you could simplify that. I'm just going to leave it, but you get your y-intercept at 0.42. I'm sorry, at, 0 and then negative 4 over negative 42. And that's all we would have to do for A. For B, and just so we're clear, yes, you could also write this as 4 over 42, positive. You could also simplify this down to 2 over 21. Either one of these three would work for writing it right here. I just am choosing not to simplify it right now, and simplifying it would be nice, but it's not something that we're forcing you to do. So this is our answer for A. So now we have B. So we set this up equal to 0. So we have these cancel out, so we're left with 5 times, we have 0 plus 11, so 5 times 11 over negative 9, which ends us up with 55 over negative 9, which is how I'm going to leave it. So I end up as my coordinate as 0, comma, negative 55 over 9. And that would be my coordinate point. So this one was kind of tricky on how to find our y-intercepts. Basically what we want to do is we want to take out our holes, and whatever is left over, we want to insert 0. So that's just kind of what we need to remember whenever we're trying to solve for our y-intercepts. These were maybe a little bit more tricky than what you might see on the quiz, but still, if you can do this, then I have full faith that you'll be able to get exactly what you need to get correct on the quiz. So now let's go ahead and do the graphing portion of this. Okay, so first thing we want to do, look, can we factor it anymore? I see that I can factor it to x plus 5, x minus 2. And x minus 1 does not factor, so that just gets left the same. So I have it factored as low as it can go. I see that I have no holes in A. Okay, vertical asymptote, I know I'm setting my denominator equal to 0. So this x minus 1 needs to be equal to 0. So I get x equals 1. Which is my final answer for that. For my horizontal asymptote, I want to look. Do I have a higher degree on the top or on the bottom, or is it the same? Well, 2 is definitely greater than 1. So I know that it's on the top. So I immediately go to bottom, which is bigger on top, no horizontal asymptote, none. So that means I have a slant asymptote. So since this is given to me as a factor, what I end up doing is I put 1 bracket, and then I do my synthetic division where I have 1x squared, 3 x's, and negative 10 as my constant. So I do my synthetic division. We all know how to do that. Bring down the 1, multiply, add down, multiply, and then who cares what this is equal to? We don't care about our remainder. We write it in the form of y equals mx plus b, which is just a linear line, right? This is your rise over run, and this is how far you shift up or down. So I have y equals x plus 4, and that is my slant asymptote. And that is all we have to do in order to solve for that. So just remember, we bring it down, do synthetic division, we write it in the form y equals mx plus b, so we're never going to care about our remainder. And this basically is just a linear line. If you get confused, graph this as well on your calculator with your graph, and you'll see that line in a different color on your Casio. So graphing this would help you on the quiz. So I highly suggest you do that. And that would be it for our slant asymptote. Okay. So next we have x-intercepts. So for our x-intercepts, we want to set our numerator equal to 0. So we have 0 equals x. We can use this, but we've already simplified it, right? We've already simplified it down to this. So I might as well use it. X plus 5, and then 0 equals x minus 2. So we've already done our work. We've already simplified it, and that's why we want to do that step first. So since we've done that, we can now just simply get x equals -5, x equals 2, and when we come here, we know our coordinate points are -5, 0, and 2, 0. And we have our x-intercepts at that point. Okay, so now we want our y-intercepts, which I can simply just, this is one where it's easier to go back to the original equation, right? Because if I plug in 0, everywhere I see an x, it's just going to be 0 at that point because it's getting multiplied by something. So I just really need to look right here, and I get 10 over 1, which is 10. So I get my y-intercept at 0, 10. And again, I get that because I kind of skipped a step there. Let me show you. 0 squared plus 3 times 0 minus 10 is going to just leave me. That equals -10. And then over the denominator, I have 0 minus 1. That equals -1. Put those over each other, I end up with 10. So I think this is one where it's easier to look back at the original equation. Okay, and here we look at our end behavior. And so I think someone asked me in class, are we going to have something like this on the quiz? And I said no, but that was my fault. I forgot that we did, and so I apologize for that. But we do look at this. It's real easy. This should be, we should be happy it's on the quiz because the only thing we need to do is look at our horizontal or slant asymptote. So since here we have a slant asymptote, we can say y goes to x plus 4. Because it's going to go towards that line. Right? So now I want to use all of this information I just got and I want to graph it. So I will label all of my stuff so I have no holes. I have a vertical asymptote at x equals 1. I have a horizontal asymptote nowhere. I have a slant asymptote at x equals 4. So basically we have a shift up 4. So our horizontal asymptote is going to look something like that. Remember, we have a rise over run of 1 to 1, right? Because we have that, it's just x. That line is not perfect. Yours does not have to be either. We know our x-intercept is at -5, 0 and 2, 0. We know our y-intercept is at 0, 10. And this is where I suggest you graph a couple in your table. I put in my table 4, and I got 4, 6. So 4 was 6, and so I went ahead and put a dot there. And I felt that was enough information I needed for me to graph. And we get that our graph looks like this. As we go closer and closer to negative, as we get further and further towards negative infinity, we're going to get closer and closer to this dotted line of y equals x plus 4. And then same thing here. So that would be how our graph would look. And another acceptable answer here, we are going down, right? So even though it does get closer and closer to x plus 4, you could also say this goes to negative infinity and positive infinity, right? Yeah, so you could say that as we go further and further, we go to negative infinity and positive infinity. So that would be another acceptable answer. I think the easiest thing to remember is it's just your slant asymptote. So that's what I would suggest you do on the quiz. So that is how we graph the first one. Let's take a look at the second one. So we need to simplify it. So when I simplify, I get x, and I'm left with x squared plus x minus 6 over x squared minus 6x plus 8. I can simplify that again, so I'm left with, and I already noticed that I can cancel out my x's. So that means I have a hole, at least one hole at x equals 0. I can simplify that down again, so I'm going to take this over here now. And I get x plus 3, x minus 2 over x, what is that, minus 6x? So x minus 4, x minus 2. Okay, so I have that completed. I notice that I have another hole at x minus 2, so I also have a hole at x equals 2. So my final simplified equation here is x plus 3 over x minus 4. So now I need to plug both 0 and 2 into that. So I get 0 plus 3 over 0 minus 4, and I'm left with negative 3/4. And I also want to plug in 2 to that, so I get 2 plus 3 over 2 minus 4, and I'm left with 5 over negative 2. And so now I know these points up here, and I will have to write it like this on the quiz, are 0, comma, negative 3/4. Excuse me. And 2, comma, negative 5/2. And so the nice thing about having it simplified down to this is it makes solving for our vertical and horizontal asymptotes much easier. I know that my vertical asymptote, I just set my denominator equal to 0. I get x equals 4. I have a same degree, so I divide coefficients. So I get y equals 1 because they're both 1. Since I have a horizontal asymptote, I have no slant asymptotes. I look for my x-intercept, and I look for my x-intercept, so I set my numerator equal to 0, and I have a simplified numerator, so I just get that it is, that would be negative 3. So I wrote it wrong on paper. So it would be negative 3, 0, because I set that numerator equal to 0. So I get negative 3, comma, 0. And a y-intercept, this is another tricky one. My y-intercept would actually be none, since I have a hole at 0. Anytime I have a hole at 0, I cannot have a y-intercept. So I have none here, NA. So now I can know that my horizontal asymptote is my end behavior, so they're both going to 1. And I can go ahead and start using this information to graph. So at x is 4, vertical asymptote, at y is 1, horizontal asymptote. I know that my x-intercept is negative 3, 0. I know I don't have a y-intercept, and I know I have a hole at 0, negative 3/4, so about right here. That's a solid point. And then at 2, negative 3/2, so about right there. Okay, so I feel like I have enough points on this side. I know that that's going to get infinitely closer to 1. And I know that I have 2 holes there, and that'll get infinitely closer to my vertical asymptote. Now I look at the other side. So what I plugged in to help me here is 6, which ended up getting me 4.5. So I got a point right there. And then I just use that information to graph. And that was all we needed to do for question number 5. And I'm starting to run a little low on time, so I'm going to have to kind of go a little more quickly on number 6. I apologize for that. But we look at number 6, and we see that we have to use the quadratic formula to simplify the denominator. So I have no holes again. And then I use the quadratic formula, which is negative b plus minus square root b squared minus 4ac all over 2a. And when I do that, I end up getting x equals 3 plus minus square root 5 over 2. So I have two vertical asymptotes here. For a horizontal asymptote, I have a bigger on bottom, so I have y equals 0. I have no slant asymptotes. For my x-intercepts, I plug in my numerator equal to 0, so I have x plus 1 equals 0, which gets me negative 1 comma 0. For my y-intercept, I plug basically 0 in for all of this, and I get 1 over 1, because I'm just 0 plus 1 is 1, 0 squared plus 3 minus 3 times 0 plus 1 gives me 1, so I'm left with the y-intercept of 0 comma 1. And I get that by just looking right there. Okay, I know my asymptotes is my end behavior, so they're both going to 0, and I can go ahead and graph. So when I graph, you might need to simplify this into a decimal in your calculator to figure out where they're at, but it ends up being that this one's at just in between 0 and 1, and the other one is just in front of the 3. Okay, and then we know that our x-intercept is at negative 1, 0. Our y-intercept is at 0, 1. And what's interesting about this is we have a horizontal asymptote at y equals 0 here. But what's interesting is this one actually goes through the horizontal axis and then is just barely under it, trying to get back over it for the rest of the time. Remember, our horizontal asymptote is not a restrictor of a domain or range. What it is it's our end behavior. It's an end behavior asymptote. So it's okay that we went through it there and we keep going all the way through. That is 100% okay. And then in the middle, in between here, we plug in 2, and I got negative 3, so I have a point right here. And this goes downwards like that, never touching either vertical asymptote. And then I plugged in 3 to get 4 on the table. And then our graph goes up, and this one actually doesn't touch it or go through it. So that would be how our graph looks here. The big thing that I want you to note here is we do go through the horizontal asymptote. But that's okay, because our end behavior, as we go further and further towards negative infinity, we're just getting infinitely closer to 0 still. And that's the most important thing. So with that, that is the end of the review. So one thing that I am doing, I have a new essential question. So in between all of these videos, I'll be telling you a random fact or something about it. So what I want you to write, if you watch this video, on the back of your quiz is what type of machine I did the review on. So you'd have to tell me I did the review on the Vivatech. And I need this for data on kind of my essential question for my student teaching. So if you watch this video all the way through, go ahead and put Vivatech on the back of your quiz, and I'd greatly appreciate it. Thanks, y'all, and see you in class.